It's fairly common at this point in the semester for you to have not covered the appropriate theory before you have to do the Kirchhoff's law experiment. That's okay, the experiment was designed for you to be able to do it anyway. But if you're finding things a little confusing, especially with your pre-lab, there is an optional help video online on the website that you can watch, and hopefully that will help clarify things for you. If not, get in touch with your lab instructor and ask them to give you a hand. You're going to be building 3 circuits in this experiment, and the first one looks like this in your lab manual, but I've actually printed it out like this because it's going to correspond more exactly to the circuit that I'm going to physically build in front of you. So just understand that what you see in the lab manual looks like this, and I've just twisted it 90 degrees to make it a little clearer in this video. Now the first thing you want to do is set up your power supply, and we want the current to be basically maxed out and the voltage to be set to 12 volts. You've got 4 knobs here, and in both cases there's a coarse adjust and a fine adjust. So the top 2 are for current and the bottom 2 are for voltage. So the current knobs, you can just twist them all the way to maximum, and then with the voltage knobs use the coarse adjust to get close to 12 volts and then the fine adjust to fine tune it exactly. So you do the best that you can with this. Now you do that as exactly as you can, but we are actually never going to use the numbers on the power supply as our data. Instead, we're always going to take data using these multimeters. Now what I find is easiest when it comes to building circuits is just to build them very, very methodically, just sequentially. Say, okay, go from the positive terminal of the power supply to the next circuit element, which in our case is the switch. And once that's hooked up, then say, okay, now I go from the switch to the 50 ohm resistor, and so on. And just work your way very methodically, very sequentially, one step at a time through it. I find that's best for making sure you don't confuse yourself. So let me show you this now. So there are 3 plugs here on the power supply. One of them's a positive one of them's a negative one, and then there's a ground one in the middle. The ground and the negative are actually connected together electrically. They've got a little metal bracket between them. So you're going to just use the positive terminal and the negative terminal. So to begin with, we go from the positive terminal of the power supply to the switch. So positive end to the power supply to the switch. And then after the switch, we go to the 50 ohm resistor. So switch to the 50 ohm resistor. And then from the 50 ohm resistor to the 100 ohm resistor. And from 100 ohms to 120. And finally from 120 to the negative end of the power supply. And then if we push down the switch, you can actually see that yes, there is some current flowing in the circuit now. By the way, if at any point you feel confused and you're not sure whether you built the circuit right, it's always okay to ask your lab instructor to come over and check it for you before you start taking data or pushing down the switch and running electricity through it. So as I said, you're going to use your multimeters to take data. The multimeter can be used to either measure voltage or current. And we are using a DC power supply, so there's 2 V's on here, a V with a squiggle over top of it and a V with a straight line. The V with a straight line is for DC voltage. If we want to measure current, we go to the A for amps with a straight line over it, so down here. I'll just turn that off for a second. You're always going to have one wire plugged into this COM terminal in the middle. If you're measuring voltage, you want the other wire plugged in here. If you're measuring current, you would have the other wire plugged in here. Now to measure voltage, I'm going to use this DMM for that. It's fairly simple. You've got 2 wires and 2 terminals, and you just plug in across whatever you're interested in. So if you want to measure the voltage across this resistor, for example, it would just be a case of take your 2 wires and plug them in across the 2 terminals of that resistor. And then we set this to the V with a straight line over it, and when I push down the switch, I get a voltage there. And by the way, if you ever see a minus sign here, it just means you plugged in your wires backward. It's not a big deal. You can just ignore the minus sign. So again, for voltage, for measuring voltage, if you say you wanted the voltage of the power supply, again, you just plug in 2 wires across 2 terminals and push down the switch, and you should get a value. Now you'll see that that says 12.13 rather than 12.0. That's the reason why we're using these DMMs rather than the numbers on the power supply, is these are actually quite a lot more accurate than the numbers on here. Now measuring current, you can actually do it at the same time as you measure the voltage because you've got these 2 meters. I'll just do them one at a time so as not to be confusing. Now you'll notice I've only got one wire plugged into here. The other wire is going to come from the circuit. Measuring current's a little more confusing looking, so I'll try and go through this very, very carefully so it's clear to you how this works. Is when you want to measure current, you basically have to interrupt the current in the circuit and force it to go through the multimeter before it continues on where it's supposed to go. So say, for example, I wanted to know how much current is going into this resistor. I would say, okay, the current's going into that resistor via this wire. I unplug it, I force that current to go into my multimeter instead, and once it's been through my multimeter, then it's allowed to continue on where it was supposed to go. So it's like I took the wire that had been connecting these two, snipped it, and forced those wires into my multimeter. So the current must go through the multimeter before it's allowed to go where it was supposed to. And again, we set this to the A with a straight line over it, and you push down the switch, and you get a current reading from that. And again, just to show you this, say you want the current coming out of the power supply itself, you would say, okay, the current's coming out of the power supply via this wire, so I interrupt it, and I force it to go into my meter first, and once it's been through the meter, then it's allowed to continue on its journey. So the place that it was supposed to go, it has to go through my multimeter first. And again, I can push down the switch and then get my reading. So now I'm ready to build the second circuit, and as before, what's in your lab manual actually looks like this, and I've just turned it 90 degrees because that'll correspond more exactly to what I'm physically building. Now I recommend that you rip out all the wires before you start on another circuit. I just find it's very easy to confuse yourself when you're trying to change connections, and it's much better to just pull everything out and start from scratch. Now the last circuit that we built was called a series circuit because all the elements just hooked up one after the other in one long series. This one's called a parallel circuit because, as you can see, these resistors are parallel to one another. I find what's easiest when it comes to hooking up a parallel circuit is to hook up that inner loop first. So just this one, very methodically like before, one after the other until you're done. And then once you've hooked up that inner loop, hook up the next one, and once that's finished, hook up the last one. So that tends to be the least confusing way to do it, is just hook up the inner loop first, and then add the second loop, and then the third one. So let me do this now. I'm going to move this off to the side a little bit. So to begin with, again, we start from the positive end of the power supply, and we go to the switch. So let's do that. So positive end to the switch. And then from the switch, we go to the 50 ohm resistor, and then from the 50 ohm resistor back to the negative end of the power supply. So one big loop like right there. So that's the first loop, and now I'll hook up the next loop. So that uses the 100 ohm resistor, and I hook up positive end to positive end and negative end to negative end. So positive to positive and negative to negative. So they're hooked up like that, or this might be useful to you. So that's the second loop. So now I add the last one, which uses the 120 ohm resistor. And again, positive to positive. So positive to positive. And negative to negative. So negative to negative. So again, they're all hooked up like that. And this one hooks on like so and like so. And again, if you're not sure if you did it right, call your lab instructor over to check. So now we take measurements off of this. With voltage, again, you've got 2 wires and 2 terminals. So say you wanted the voltage of this resistor in the middle, it would just be a case of take your 2 wires and plug in across the terminals of those 2 terminals of that resistor. So just like that. And you push down the switch and get your value. And again, current is slightly confusing, so I'll just go through this a few times. So say you wanted the current going into this resistor, you have to interrupt the current that was going in there, force it to go through the meter first, and then it's allowed to continue on where it was going. So the current is going into this resistor via these wires, so you unplug those, put them into the meter, so the current is forced to go through the meter first, and then it's allowed to go on where it was supposed to go. So like that. And then again, push down the button and get your value. Likewise, say you wanted the current coming out of the power supply, you interrupt the current where it was supposed to be going, force it into the meter, and then it's allowed to continue where it was supposed to go. Now this is the third circuit, and I'm not actually going to build this one for you, but I will note that again the easiest way to build it is to hook up this inner loop first, one circuit element after the other, and when that's all hooked up correctly, then add the next loop out. Now the first circuit that we built was called a series circuit, the next one we built was a parallel circuit. This is a combination circuit. We've got some circuit elements in series with one another and some in parallel with one another. So again, if you're not sure whether you hooked up your circuit right, feel free to ask your lab instructor to come over and check it before you actually start taking data.